Hi friends, welcome to my channel FreakingIT. So today we are going to discuss the topic STP. So what is spanning tree protocol? We are going to discuss the spanning tree protocols, and we are also going through the lab, how the lab is work, how the spanning tree will work. So let's first discuss what is spanning tree protocols. So spanning tree, we can call it short as a STP. Spanning tree is a layer 2 protocol. It defined by IEEE 80.1d that ensure a loop-free topologies in bridge Ethernet networks. It dynamically disables redundant paths that cause broadcast storm, multiple frame copies, and MAC address instability. So in the spanning tree, mostly when this question will come when you're giving the interviews. So spanning tree basically is loop avoidance protocol. The short form is. So that's why we required spanning tree. So let's discuss how it's work, how the loop is preventing because everybody say the loop free topology, how it's work. So spanning tree uses a distributed algorithm to elect a single root bridge and then calculate the shortest path from all the switches to his root. Here the step-by-step procedure. First is bridge ID. Each switch has unique bridge ID composed of priority plus MAC address. So bridge ID or each switch has their own bridge ID which provide the unique recognitions of each switch. Second is the root bridge election. The switch with the lowest bridge ID become the root. So I'm giving very simple example. If suppose in a network we have 10 switches and suddenly all switches will come up. All setup is new. So there will be election happen. Who will be the root bridge elect? Who will the root switch or root bridge? So the root bridge election help with the bridge ID. Path cost selections. Now, okay, how the path is calculated in spanning tree. STP assign a cost to each link based on the speed. Lower cost equal to fastest link. And after that, we the switch find the shortest path BPDU exchange. Switch share BPDU protocol units to communicate topology info. If somebody asks the question how the switches are communicate through each other, if any protocol, the BPDU is the packet which is sending each network. So what are the port roles? Now election is happen in spanning tree. We already discussed like okay, this is a bridge ID, root bridge election, path cost calculation, BPD exchange. What are the port roles? Because once the spanning tree established, you will find some state of ports. So you need to understand. It's a root port, which we call RP. The best path to the root bridge is called a root port. Other one is destination port. Best path to a segment where the packet need to travel. Block port. Block port basically is a redundant port that could cause a loop in and disabled. So how they cause suppose if we have connected one switch to cable with the same other two switches, it will create the loop. Switch will get confused where he need to send the packet. So that's why they are doing the BPD elections. So next is the stages which we learn how the port transition through the states. First is blocking, listening, then learning, then forwarding. I am again taking the example. Suppose in a network you have 10 switches. If all switches are come up, they will do the election. One of the switch who will master, there is a root port and destination port. The other switches which we have two states, one is block port and one is root port. Because one switch is disabled because they stop the loop because switch is considered that this is looping because looping. If you connect again two cables with one switch from the remote side switch, so switch is getting confused where he need to send the packet. So they will do the election, this process. So this is as spanning tree protocol is playing very vital role in our network to avoid the loop. Come to why STP is required now. We already discussed the states, but why we require. So without STP network with the redundant path can suffer. We don't have redundancy in our switches because suppose as per standard you want to connect two cable to your end user switch. One cable goes to primary switch, another cable goes to secondary switch. Your redundant path will not work if we don't have STP. The another major concern is broadcast storms. Endless circulation of broadcast frame which cause a slow network, loop, MAC table instability. Switch constantly update the MAC address and it will incorrectly because the switch which making the MAC address it we also called a CAM address table. So if they getting this information from both the different sources, so they are not able to update their MAC address properly and their MAC address is wrong. Table we updated wrongly and it was creating a lot of issues in network. Multiple frames copy. So duplicate frame confuse endpoint. Switch don't know where to send the packet because they are receiving the request from same request from two different port. They are not able to understand where we need to give. So that's why STP, what the STP provide? STP ensure network stability, resilience, and efficient communication by allowing redundancy without loop. So this is the spanning tree loop lab which we are going to do on packet tracer. I am taking you guys on the lab and where I will show you like this orange port where I'm taking the scenario. Let's discuss. This is my core switch of my organization. I connected to end user switch and this is my end user. So we are going to check how the STP will work and how the STP will help us to provide the redundant reachability to this 888 loopback. So this is the lab where we have different core switches. So this is our core switch, which IP I have given 4.4.1 to VLAN 10. I have configured the DHCP here. So this, let me check this machine IP. I will show you the machine IP. Sorry, give me one sec. So so if I will check my machine IP, the IP config command, it will show my IP is this one 4.4.5. Okay, so this user is sitting here and this IP is here. When I'm trying to ping this IP is ping.8.8.8. is reachable. So this network is already established because this class is related to STP. So let's discuss the STP. So this core switch, let me log I let me log into core switch. So I log into core switch. Now I am checking show spanning tree. When I'm checking a spanning tree, it will show me two stages. See what we discussed. One is the root port forwarding and other one is the alternate which is blocking the port. It is blocking the port. So when I'm checking here in my this switch, what is the stage of spanning tree? Show spanning tree. So see, one is root port and one is the designation port. So this switch is a master which this switch has a right to decide, okay, to consider this as a root port. This, so what is the port 0/2 is? So this switch is decided, okay, my traffic will go first here, then it will reach here, then it will reach to here, then it will go and reach here. But even this path is near looking nearby, less hope, but still this switch is considering this path is okay for me. Okay, then let okay, let me first I will already show you the my ping response of this machine is I think it's pinging, IP is pinging. So what I am going to do, I am going to shut down this interface because I am going to show you the how the redundant path is working on STP. So currently traffic is going from here to there. So what I am going to do, I am going to shut down. So it's a fast Ethernet 1 config T interface fastnet 0/1. I shut down this one. Okay. Let's see what is happening now. Let's see what is happening. So this port is down. Okay. I'm trying to ping again. It maybe it will take time. See, it is because election is happening. Election is happening. See, this is still time election is happening. So see, I am able to ping 888. So, but this path is totally down. See this path and the traffic will start going from here. Let me see what is the stage of this show spanning tree. When I'm clicking show spanning tree, so currently I have only designated forwarding port, and both of 3 and 01 is a designating forwarding port. Any switch which is a root bridge, they have both ports are designated forwarding port. No port is the block state in the root switch. But if you check here, if I'm checking here, show spanning tree. So because see, currently it's down, path is down. So show. So if I will check here, here the main thing, see that what shows spanning tree. So here is a root forwarding port which is port 02. If I will check and what is the port for 02? This one. And I see my ping response. Still it's working as a if let me no shut my port. We'll see that what is the difference then. So I am reshutting no shut my port which is interface fastnet 0/1. I am no shut. Let's see what happened now. So I need to check my path is still establishing. So I'm waiting for it will take because this is a packet tracer. The convergence of this will take time. So we need to hold for this video for some few minutes. So let me pause this video. Once the ping will back, I will show you because it video is already lengthy. Okay, so see you can see that it ping is started now. Now see the path is from here from switch 0 to switch 1 and it's going to here. So this is the topology where the spanning tree work. If you see the state now shows spanning tree. Spanning tree now you will get this stage. One is root port, one is a block port. But this is I am again asking this switch is not a root bridge switch or master switch. This is a master switch because when you see the spanning tree here, you will find both the ports. One port is a forwarding, another port is a designated port. And please remind this is a question asked in the master switch ports are which state. So master root bridge switch ports are one is a root bridge and another port is a destination forwarding bridge. It's not if you are checking the any other switch, see this switch is here, even the name is core, but the election happened, the election lost, and that's why this switch has one port is block port and one port is a root port. So I believe this lab is clear for you. It is only simple spanning tree lab. You know what we discussed, like both ports, how the blocking state is there, how the calculation is happening in the spanning tree, how the redundant path is there, which I clearly show you guys that how my continuous ping I am getting. Still it is pinging. Now the path is, see this path is down. Now I and down if this between, but still I am able to send the packet to here from here. It is a auto calculative. We don't need to do any manual intervention. So this is purely spanning tree protocol, which is very important topic for exam. So I have made this video only for understand what are the state you can getting on the spanning tree. The spanning tree, I am again repeating the same definition. The root switch is the switch where we have both port. One is for forwarding port and one is root port. I have root switch don't have any blocking port. In the block in the end user switch you have blocking port and one is root port. So I hope this video help you to gain some knowledge. I am also in learning stage, so please support to subscribe so that I will make more channel. If you need more clarity, please put in the comment box. And thank you for support.